السلام عليكم جميعا. شكرا على الحضور، وإن شاء الله يكون في المحاضرة هذه فائدة نطلع بها جميعا. اليوم أنا راح نتكلم عن الكربون كابتشر اند ستورج تكنولوجيز. كان تقدر تسألوني في أي لحظة إذا عندكم أي استفسار. الأوتلاين المحاضرة راح يكون على الشكل الآتي. الأول راح نتكلم what is CCS what is carbon capture and storage. بعدين يجي الجلوبال CO2 emissions والسورس اوف emissions، وبعدين الجلوبال CO2 captures والسي سي اس ماركتس وورد وايد. نتكلم بعدين عن الكابتشر تكنولوجيز والسيبريشن تكنولوجيز والترانسبورتيشن اوف CO2، والاخير راح نتكلم عن ستورج واليوتيلايزيشن. What is CCS? CCS technology capture CO2 emissions at source. Source هذا يمكن يكون power plants, cement plants, refinery, or can be directly captured from the air. So CO2 emission are then transported away and stored deep underground or turned into useful products. Capturing the carbon has been used for decades to help improve the quality of natural gas. But pioneering new technologies means we can now remove and sequester CO2 for long periods of time. And long period of times it could be hundreds or thousands of years. And we are exploring new ways to add value to the waste CO2 by turning the gas into a marketable industrial and commercial products. Global CO2 emission. ناخذ the countries with the highest carbon footprint. يجي في المركز الأول China. China has contributes to more than 11 million metric ton of CO2 per year. Second place يجي United States of about more than 5,000 million tons of CO2 per year. India is third place. Russia المركز الرابع، وبعدين يجي اليابان and so on. So واضح ان industrial city countries contribute the most emission worldwide. Countries emitting with the most CO2 per capita. Surprisingly الدول الخليج تكون في التوب. عندك قطر contributes 37 tons of CO2 per capita a year. الكويت تجي في المركز الثالث ب 20.8 per capita، والمملكة المركز الرابع ب 18 per capita، وفي بعد الإمارات تجي 7th place or 6th place بال 15.2 per capita. Saudi Arabia has a number of international commitments to reduce carbon emission. The first one is the Paris Climate Agreement. Paris Climate Agreement states that global temperature increase need to be limited to 1.5 degrees Celsius above the pre-industrial levels. Emission to be reduced by 45% by year 2030 and reach net zero by year 2050. Mission Innovation. Saudi Arabia is a part of Mission Innovation. And what is Mission Innovation? Mission Innovation is a global initiative to invest in research and development to make clean energy affordable, attractive, and accessible for all. Then comes the Kyoto Protocol. Kyoto, by the way, it's a name of a city in Japan. Kyoto Protocol is an international treaty adopted back in 1997 that aimed to reduce the greenhouse gas emissions by 5.2% below the 1990 levels. Source of carbon emissions. Electricity and heat production comes or contributes the most emission globally. In year 2019, production of electricity contributes to 34% of the global emission. And the burning of coal, natural gas, and oil for electricity and heat is the largest single source for global greenhouse gas emissions. Then there come the industries. Industries emission from industry primarily involve like fossil fuels burned on site at facilities for energy. This sector also include emission from chemical, metallurgical, and mineral transformation process not associated with energy consumptions and emission from waste management activities. The industry sectors contribute to about 24% of the global emission. Agriculture, forestry contribute to 22%. Emission from this sector come mostly from agriculture, cultivation of crops and livestock, and deforestation, as what's happening in South America, especially in Brazil, the Amazons. Transportation contributes to about 15% of the global emission. And then comes buildings. Emission from this sector arise from like on-site energy generation and burning of fuels for heat in buildings or cooking in homes. And it's about 6% of the global emission comes from buildings. Global CO2 captures. There are now around like 45 commercial capture facilities in operation globally, with a total annual capture capacity of more than 15 million tons of CO2. In 2023, announced capture capacity for 2030 increased by 35%, while announced storage capacity rose by 70%. This brings a total amount of CO2 that could be captured in 2030 to around 435 million tons per year, and announced storage capacity to around 1,615 million tons of CO2 per year. The United States announced important opportunities in 2023 that are expected to boost CCS project development, including $1.7 for carbon capture demonstration projects and $1.2 billion for direct air capture. Then comes the European Union. European Union issued around 1.5 billion USD to CCS project under the latest innovation fund round, and over 500 million US dollars to transport and storage projects under its Connecting Europe facility program. Japan is quickly advancing in CCS efforts with the selection of 7 large-scale projects to capture and store around 30 million tons of CO2 per year in 2030. When it comes to the CCS market, North America held the largest market share of more than like 35%. So this market is expected to increase by 27.3% by the year 2030 to reach more than $17 billion. Now we start with the capture technologies. There are like different capture technology that enable us to capture CO2. The first one is what they call direct air capture. Direct air capture is a technology that removes carbon dioxide from the atmosphere directly. This graph can help you to understand the process of the direct air capture. So how does it work? By using high-powered fans, air is drawn into a processing facility where the CO2 is separated through a series of chemical reaction. And then the CO2 is either permanently stored in underground reservoirs through secure geological sequestration, or is used to make new products such as building materials and low carbon fuels. Second technologies of capturing CO2 is called post-combustions. Post-combustion CO2 can be captured from the exhaust of a combustion process. absorbing it in a suitable solvent. The absorbed CO2 is liberated from the solvent and then is compressed for transportation and storage. Certain solvent absorption processes are technically mature. The potential for emission reduction depends on the CO2 capture ratio, which is CCR, and the amount of heat or power required to drive the capture process. Now we come to the third technology to capture CO2. It's called pre-combustions. So pre-combustions capture refers to removing CO2 from fossil fuels before combustion is completed. For example, this graph can show you the process of the pre-combustions. So, for example, in gasification process, the feedstock, such as coal, is partially oxidized in steam and oxygen under high temperature to form what they call syngas. So this syngas is a mixture of hydrogen, carbon monoxide, CO2, and a smaller amount of methane. The syngas can then undergo the water-gas shift reaction to convert CO and water to CO2 and H2, producing a pure H2 and CO2 rich gas mixtures. And then the oxy-fuel combustions is the fourth technology to capture CO2. Oxy-fuel combustions is regarded as one of the most promising carbon capture technologies to mitigate the climate change, which has been studied and demonstrated in academia and industry as well. It relies on the fuel combustions of fossil fuels and oxygen separated from the air to obtain CO2 and water vapor. Subsequently, CO2 and water vapor are separated by condensation and captured CO2 is stored, and the captured CO2 is stored. Then the last technologies of capturing CO2 is called chemical looping combustions. It's a form of oxy-fuel combustions in which oxygen is introduced to the combustion reactor, not as a gas, via a metal oxide carrier, which is either fully or partially reduced in the combustion reaction. Okay, after capturing CO2, usually it comes with it's in a mixture. So the separation technology has to get involved to separate CO2 from other gases. So there are different, I would say five technology to separate CO2. One is called chemical absorptions. So chemical absorptions consist of the moving of carbon dioxide from gas phase to liquid phase. And then in the liquid phase, a chemical reaction occurs, resulting in the absorption balance being moved toward the product. That's carbon dioxide in a bound form. And second one is the physical absorptions, in which a solid absorbent, such as activated carbon, is passed through the gas stream, and the CO2 is held on the surface of particles by surface forces. Once collected, the particles are heated, releasing the CO2. Then the chemical adsorptions. It's a method used in the industry mainly to purify and recover gases. That is the separation of air, recovery and purification of hydrogen, separation of CO2. And then membrane. Membrane technology is a selective barrier separating ingredients from the flue gas stream through the membrane to the permeate at various velocities. Cryogenic CO2 capture. It's cryogenic CO2 capture used phase change to separate CO2 and other pollutants from the exhaust or process gases. So once CO2 is captured, then the second technology or second components of CCS is the transportation. So there are different ways of transporting CO2 to the storage sites. The most common one is the pipelines. Pipelines are likely to continue to be the most common method of transporting very large quantity of CO2 involved in CCS. There are already millions of kilometers of pipelines around the world that transport various gases, including CO2. So it's a mature technology nowadays. CO2 also can be transported by trucks, and rare it's possible for small quantities. Another media of transportation is the ship transportation. It can be an alternative option for many regions in the world. Third components of CO2 CCS is the storage technology. So CO2 storage is defined as the placement of CO2 into a reservoir, such that it will remain stored permanently, I would say forever or for hundreds and thousands of years. This is the final step of the carbon management. There are two ways of storing CO2. One is geological storage, and second one is ocean storage. Geological storage is underground storage of CO2 in geological formation is the most developed disposal option for CO2. There are different ways of geological storage. The first one is the oil and gas reservoir. Oil and gas reservoir are pores, rock formation, usually like in sandstones or carbonates containing hydrocarbon, such as crude oil or natural gas that have been physically trapped. Oil and gas reservoirs are ideal because they have shown to be impermeable over millions of years and have conditions suitable for CO2 storage. Another type of underground storage is the unminable coal. High pressure CO2 can also be used for enhanced methane recovery for coal. This is considered unminable because of geological, technological, or economical factors, such as either it's too deep, too thin, or lacking the internal continuity to be economically mined with today's technologies. Coal absorbs CO2 over methane, which is naturally found in coal seams. And then there comes the deep saline formations. Deep saline formations, aquifers, are highly porous sedimentary rocks, which are saturated with a strong saline solution, such as brine. Compared to coal seam or oil and gas reservoirs, saline formation are more common and offer the added benefits of greater proximity, higher CO2 storage capacity, and fewer existing well penetrations. Basalt formations, another type of geological formation. Basalt formation, which is the formation of solidified lava, have a unique chemical makeup that could potentially convert all of the injected CO2 to solid mineral form. And then there came the shale basins. Shale basins is sedimentary rock and is characterized by thin horizontal layers with very low permeability in the vertical direction. Many shales contain 1 to 5% organic material, and this provides an adsorption substrate for CO2 storage, similar to CO2 storage in coal seams. There are some uncertainties when it comes to geological storage. First of all, due chemical process such as the dissolutions of carbonate rocks through acidic CO2 water mixtures. The second uncertainty, the pressure-induced process such as the expansion of existing small fissures in the sea rock through the upper pressure of CO2 injections. And also the possibility of leakage through existing drill holes, or the possibility of leakage via undiscovered migration paths in the sea rock. lateral expansion of the formation of water, which is displayed by the injection CO2. The second type of CO2 storage called ocean storage. Potential CO2 storage option is to inject the captured CO2 directly into the deep ocean, where most of it would be like isolated from the atmosphere for centuries. Deep ocean, usually at depth of 1 kilo to 3 kilo. Deep ocean injection is the option that would offer like long-term sequestration. This can be achieved by transporting CO2 via pipelines or ships to an ocean storage site where it's injected into the water column of the ocean or at the seafloor. It's worth mentioning that the CCS process is very costly. In order to offset the cost of CCS, CO2 can be utilized in different commercial products. For example, chemicals. CO2 can be transformed efficiently into a range of chemicals, but only a few of the technologies are economically viable and scalable. Some are commercialized, such as the production of urea and polycarbonate oils. Also, CO2 can be used in concrete building materials. CO2 utilized pathways in concrete building materials are estimated to utilize and store between 0.1 and 1.4 gigaton of CO2 per year. Carbonated beverages, like soda, carbonated drinks refers to beverages which have carbon dioxide. The process of dissolving carbon dioxide in drink can be occurred naturally through fermentation or artificially by the injection of CO2 to the beverages itself. And then fuels and microalgae. Fuels derived from CO2 are argued to be an attractive option in the decarbonization process because they can be deployed within existing transport infrastructure, such as fuels, also find a role in sectors that are harder to decarbonize, such as aviation, since hydrocarbons have energy density that are orders of magnitude above those of present-day batteries. The most promising one is the use of CO2 to enhance oil recovery. This is a mature technologies, and it's been used like back in the 70s in the United States, especially in the oil field in Texas and in New Mexico. So how does it work? Storing carbon dioxide in oil reservoir as part of CO2-based enhanced oil recovery can be a cost-effective solution to reduce emission into the atmosphere. So the injected CO2 enters the reservoir and moves through the pore space of the rock, encountering residual droplets of crude oil, becoming miscible with the oil and forming a concentrated oil bank that's swept toward the producing wells. And Aramco is using this technology in Al Ghawar oil well. And this technology can help to increase oil production in the field by like 20 to 40% from the original oil in place. Thank you so much. I'll be more than happy to answer your questions if you have any.